Well, normally I'd wait a few more minutes and let people trickle in, but we do have a packed agenda. So I'm going to say welcome everybody to our webinar on the specifically the CCUS, carbon capture, use and storage tax credit webinar. Today we wanted to just do a quick run through of the State of the Union, a few updates on the tax credit that has been certainly long in the making, just about 2 years now, announced initially in budgets a few years back, and give a few updates. And then really wanted to dive into showcasing the technologies that are out there and the breadth of technologies that are in CCUS. We often get very much focused in on one certain type of storage or one certain type of capture for CCUS because it grabs some of the headlines for certain industries across Canada. But there's actually a very diverse set of different technologies that are being applied in this space. So with that, just a couple of housekeeping notes. We are recording. We'll post this shortly after we have finished up and have a chance to post-process. Please mute yourself for those that are not. And questions, you should be able to put those in the chat. We are hoping to have about 10 minutes for Q&A at the tail end after the showcase. We'll try and manage time accordingly, but please do put them in the chat. If we can't get to them during the webinar, I will try and reach out afterwards. So with that, of course, a man of many hats. If you have any tax credit financing needs, certainly reach out. Traditionally, Venbridge has focused on the SR&ED tax credit, but there's these other tax credits that are coming down the pipes that might look a little interesting. So, watch this space, and we'll be chatting soon. With that, I also want to thank all of our partners, EDC, of course. So we've got Jeff Keats joining us here, and we'll say a few words in a moment. City of Toronto, Swan Law, Venbridge, and the Canadian Open Data Society. And with that, I'm actually going to turn it over to Jeff to say a couple of welcoming notes, and then we'll dive into a little bit of the updates.
Yeah, thanks, Brian. Really appreciate the chance to be here and to hear from you and the other speakers to learn more, and really much value the partnership with you and CleanTech North, realizing also you wear many, many hats. At Export Development Canada, or EDC, CleanTech's been a corporate priority of ours since 2012. And last year, we were fortunate enough to support well over 400 CleanTech transactions in sort of hundreds of Canadian CleanTech companies. And thanks to Brian for being just a piece of that support. As you know, CCUS will be a vital part of decarbonization and the energy transition. And it's amazing to see we've got some fantastic CCUS companies and technologies in Canada. There have been some challenges in some of the economic viability until now, so really curious to see how the tax credits can be a piece of this puzzle. And I'm really here to learn. So thanks for having me, Brian, and back to you.
Always wonderful to have you here, and look forward to updates on things like Export Week and various other things for the fall. So with that, I think it's probably worth jumping into the first part of our agenda, which is really a little bit of an update on the CCUS, carbon capture, use and storage tax credit, where we sit right now. We'll have a little bit of a note from myself, a note from Corey Conroy from EY, who's joining us. Thank you, Corey. And Jonathan Garbutt from Dominion Tax Law, who has a couple points that we want to raise. We're not going to get the waterfront of the entire 50-page draft legislation. But we will certainly touch on where we're at with it, and any specific questions. Again, please use the Q&A function. All right, so CCUS ITC. It is a refundable ITC, so again, that means you do get cash back. These are a couple questions that I keep getting, so I'm putting them back in here. And the technical authority for the CCUS is Natural Resources Canada, who are providing an imprimatur on the projects that is necessary to claim that tax credit. As far as we know, there will be a little bit of guidance provided shortly, hopefully, on what that looks like and how to go about getting that stamp of approval, that imprimatur. But they are doing the technical assessment on the projects, whereas CRA is processing the back end and is actually being processed by the Shred Directorate, because these really are probably the closest genetic neighbor to Shred as programs in the federal government ITC program. Very quick notes on the ITC itself. Again, won't run through all the mathematics, but basically any of the capital cost equipment that goes into direct air capture, the transportation, storage, and use of carbon. So whether that be plugging into the flue stack and capturing it there, or direct air capture, and then transforming and using that carbon or storing. Any of the capital costs associated with that can be recaptured part thereof by this tax credit. Various different rates depending on which part of that capture use storage equation the capital is being used for, but it is that is the basis of that tax credit. These can be applied retroactively to Jan 1, 2022. So if folks have project costs they incurred over the last 2 years, those can be claimed. I don't believe we have guidance yet on the 18-month window to restate your taxes. So there might be a bit of a flurry of activity in June if you've got a December 2022 year end to amend tax claims to include these. But it's certainly something to watch if you do have project costs in there. And I don't know, Corey, if you have any insight on that part, but I haven't gotten any guidance on that yet. No, that doesn't sound like it. Okay. And budget 2023, Corey's going to cover a little bit on 2024. We did add geological storage in there as well. The most up-to-date, as of yesterday, process of the Bill C-59, which is the bill that houses both the CleanTech and the CCUS tax credit, is that we are now in third reading. They have set up what is called time allocation and set up 5 hours allotted to discussing the bill, basically a way of pushing things forward quickly. Because it's certainly, as you can see, the dates of the first reading, November 30th and March and May, it's taken a little while to get the fall economic statement bill done. So they've put time allocation on there to accelerate that process. And one thing that was committed to in the budget 24 a month or so ago is that the Bill C-59 will be passed by June 1st. So that likely means that it will be passed third reading. Might still have to go to Senate. It does still have to go to Senate, and it does still have to get royal assent. But certainly we expect at this point that it's a matter of days, not even weeks or months at this point. So it is moving. Finally, very happy to say that. And there is a working group that's providing some feedback and then getting some insight on this so that we can help companies claim this as soon as possible. With that, maybe I'll turn it over to you, Corey, to chat about what we saw in 2024 budget and where things are going.
Yeah, you bet. Thanks, Brian. Yeah, the black box basically covers off what Brian covered in the first few slides there. I was maybe a bit more optimistic, hoping we would get all the way to royal assent by June 1st. I don't think that's realistic at this stage, but passage by June 1st would be a nice signal by the government that they are serious about getting these incentives formalized. On the right-hand side, sort of some noteworthy developments over the past couple of years. So the federal ITC was expanded to include DC for sequestration, and the ISO, mineralization threshold for concrete was also set out. So that's already been sort of spoken about. In 2024, I think most people read past the capital gains exemption, but there was a brief mention of CCUS in that budget around the clean electricity ITC. So projects where you're perhaps burning natural gas to generate electricity where you're appending carbon capture off the stack. There's an opportunity, of course, for a project to attract multiple types of ITCs, but again, they're pretty clear that one expenditure cannot attract multiple ITCs. So the CCUS side would, of course, attract the CCUS ITC. That's generally going to be more lucrative. And then the rest of the project that qualifies would attract the clean electricity ITC, which is still sort of being baked right now. I'm based in Calgary, so there's lots of discussion on what is lagging lately. There's general consensus that there needs to be a bit more action on contracts for differences. So right now there's one publicly announced contract for differences with the Canada Growth Fund with Entropy at $86.50 a ton for 15 years. Obviously, that's a bit behind the IRA incentive in the US. So there's that sort of headwind that we're seeing on these projects. And then, you know, also notably absent, in addition to legislation, is the pre-approval documents from NRCan remain unpublished, as are the prescribed tax forms for CRA. So I'm speculating, Brian, but an 18-month filing surge requires some tax forms, and they don't exist yet. So yeah, but can confirm as well that folks from the SHRED program are now migrating over to take over responsibility for administering the tax credit. At least locally, we've heard that. So you know, they are mobilizing to be ready to handle this, which is good. And then lastly, I realize this is somewhat regional, but the Alberta Carbon Capture Incentive Program was first announced broadly in late 2023, and then received sort of an updated overview in late April of 2024. So this ACIP program builds off of the Petrochemical Incentive Program grant, which is a 12% grant on top of any ITC for CCUS. So it is stackable. And the guidance last month was interesting in that the government is signaling its intention to support EOR, which is not included as an eligible use case for the federal ITC. And they're also expressing the potential to include the additional class 59 for, you know, geological and seismic and various other costs, and then the drilling and completion of storage wells. So anything that falls into class 60 may also qualify. So a bit of an enhanced benefit for CCUS here locally in Alberta, and a bit expanded as well in terms of the eligible work that we will support. And that legislation has been promised to follow the federal CCUS ITC to make sure everything's sort of aligned. So those are what I kind of picked up as notable developments, in addition to what you've covered already, Brian.
Great, thank you very much. And one thing I will say is, and certainly I don't have an exact timeline, but I do know, you know, forums are prepared, and it sounds like web content is prepared as well for guidance that hopefully is made public very shortly after the legislation passes. Of course, you know, until there's legislation, publishing any sort of guidance, it could be tweaked at the 11th hour. Not that I expect that, but I don't see a huge time lag between legislation passing and that guidance coming out. But again, we wait and see. One other thing I'll throw out there is sort of deficiency that I see in this suite of tax credits relating to CCUS, and it may be relevant to some of the companies that are out there that are presenting today, but also some out in the ether. Currently, in the manufacturing tax credit, and that's not where we're focusing today, but currently CCUS equipment isn't contemplated under the manufacturing tax credit for some reason. So this is certainly something that we're trying to get to the bottom of, see if that's a oversight or what have you. But certainly, given we're giving up to a 60% tax credit, I would hope that the manufacturing base of Canadian technologies would be supported for that that supply chain to be generated domestically. So it's an area that we are watching. It's not part of this ITC because that is manufacturing of the equipment to manufacture the CCUS equipment. So it's the capital cost of that manufacturing equipment. But it certainly would impact the companies that we are showcasing. Jonathan, any key points from you? We've got a couple minutes because I know our first company has to present and has a hard stop. Jonathan?
Yeah, no, very quickly. Two things, first of all, that the key issue with this is that the rubber is yet to hit the road, and there was just recently a major project that was announced that was being canceled, even as all this is starting to come to fruition, just because they said the economics weren't there. And one of the things that people are looking for is this certainty, consistency, and fairness in the legislation. And so there's still a lot of uncertainty out there about how this is going to be applied. Now, the good news with the CCUS still, as always, is that this one, the technical is going to be not done by the CRA, and I think that is probably the biggest advancement towards certainty and predictability, and the fact that you can apply in advance and get yourself certified, which you can't do for any other type of credit, I still think is a great boon to the industry, and is probably more important than people think, in terms of there's nothing worse than getting into a project and you're doing something and you're certain it qualifies, and the CRA just going, no, because it's Tuesday, and they don't seem to have the technical wherewithal. And this is the first acknowledgement from the CRA that they do not have perhaps the technical, omniscience that they kind of pretend they do with shred claims. That's the first one. So that's a good thing. The downside part for me is still in the structuring. I've been on this from day one. The way that they've set it up is they've have this vision that you're going to have a company, and it's going to be a corporation, and they're going to do it all inside the corporation, and it's just going to be an add-on to existing corporations. They do not have the idea that this is somehow a way that tax credits can be a way for you to literally bring money in. Like, they're looking at this from the perspective that it's kind of like a shred credit where you're already doing it anyway, instead of as being these credits and the depreciation schedules and everything else could be a vehicle to generate funds into this industry if they allowed it to become sort of an investment vehicle that would sort of allow companies in some ways, like I said, to, and from the technology company's perspective of, rather than them having to sell to a client, them being able to say, we're doing it with or at a facility, and by the way, it's only going to cost $50 million, and we would like to raise that via some form of limited partnership or some other structure. That's not something the government has been willing to sort of explore or look at. So they still have a very conventional look at it. So good. So still questions out there. Good news. Yes, thank goodness it's NRCan that's deciding the tech, but they still haven't sort of gotten with the program in terms of seeing this as being a way to raise funds into the industry. And so I'm going to still keep complaining about that nonstop. So anyway, like I said, why is this being treated like shred when it should be treated like flow, where we can raise money through this? That's the problem that I have with this at this point still. So, and they haven't clued into that. So we'll keep harping on it. Hopefully it'll get through. That's it. That's my story. I'm sticking to it. I'm done.
Wonderful. And I will say, having been in the shred world for a while, this is actually probably the most responsive that I've seen from a policy and legislation perspective. They've actually been adopting things as the subsequent budgets have come out, where there have been holes that have been identified. So hopefully some of those holes retroactively, Jonathan, can be plugged to allow that to become a wonderful vehicle. Now, you mentioned the project that was canceled. One of the reasons we wanted to do this this webinar with a sort of pantheon of different types of technology technologies in this space is that not all projects are just oil and gas projects. Some aren't, and that's fine. But there's really quite a vast variety of them. One of those is our wonderful friends at Deep Sky, and I wanted to get a bit of a snapshot as to where things are at from my fellow Clean 50 alumni, Phil Loon. So Phil, I'll pass it over to you. I don't know if you have slides or if you just wanted to speak to it, but let me know and I can stop sharing.
Thank you so much, Brian. It'd be great if you could enable participants screen share. That'd be fantastic, so I can share screen. But while you change that, so I can do that, maybe just to first kick off and say I've really enjoyed this conversation on the CCUS ITC, especially because it's very pertinent to us. Literally, an hour ago, we had an in-person session with EY to discuss how exactly we're going to look at SHRED versus CCUS ITC over our last fiscal year's budget. So it's been a day full of taxes for me, which is great. I don't necessarily, it doesn't seem like I can share a screen, so I'm just going to go ahead and talk. For those who aren't aware, Deep Sky, we are a technology agnostic project developer in the carbon removal space. And what that means is that rather than develop technologies ourselves, we are focused on developing projects and trying to get to scale as quickly as possible. A way to think of us in other carbon removal companies is as an oil and gas company in reverse. Oil and gas companies take carbon out of the ground, extract energy, carbon goes into the air. We take carbon out of the air, use renewable energy to compress and liquefy it, and then we store it underground permanently. And then we generate a carbon credit from that, which we sell to the voluntary carbon market. For a bit of background onto Deep Sky, and I guess I should introduce myself. So I'm the chief carbon scientist and head of engineering at the company. I'm responsible for everything on the capture side of our business. Deep Sky was founded about 16 months ago, by our co-founders, Fred Lalonde and Joost Overkirk. They founded a company 17 years ago called Hopper. You may have heard of it. It's a travel marketplace, the second largest privately held tech company in Canada after Shopify. Latest valuation was $5 billion.
No, you should be able to share now, just so you know.
Oh, perfect. Great. Okay, great. So the story of I'll start here. The story of Deep Sky really begins with Fred and Joost, who are at the top left-hand corner here. A few years ago, they started offsetting the emissions of their customers by planting trees, and they planted 40 million trees over 4 years or something like this. They thought they were doing a great job, and it started them on their climate journey. And they realized two things. One, that climate is changing far faster than even our most progressive models have predicted. And two, that planting trees is not enough. It's not permanent. When a forest fire occurs, that carbon that was stored there literally goes up in smoke. And from a mass and energy balance point of view, it kind of makes sense. We got into this mess by taking carbon out of the ground and putting it into the air. We kind of have to reverse that if we want to get back to climate stability. And so we launched Deep Sky. They launched Deep Sky a year and a half ago with the intent of scaling and focusing on scaling carbon removal projects. If you look at other tech verticals, whether it's solar, wind, natural gas, or renewable natural gas, etc., you have technology developers and then you have project developers. Panasonic builds solar cells. They're not Bullfrog Energy or TransAlta or whoever else building the solar projects in your backyard. Why should that be any different for carbon removals? The only difference is that it's such a nascent space and the technologies are so different that we don't know which ones are necessarily going to scale. And so that's why we have decided to be a technology agnostic project developer, where we partner with technology developers to identify which technologies will scale and then build commercial projects around them. The need for this is really driven because of carbon commitments. 42% of the S&P 500 had science-based targets initiatives to get to net zero in 2022. That's only increasing as time goes on. You can see that on the graph. I'm going to skip over a bunch of this stuff because it's a lot of commercial, and really all is to say is that the demand for carbon credits is increasing drastically, and avoidance credits themselves are not going to be considered carbon offsets in a few years. And so we're focused on carbon removals and high quality, durable, permanent carbon removals using direct air capture because it's highly permanent, highly measurable, has the MRV in place, and is ITC-able, frankly. So we are trying to build the world's first IP agnostic project developer. As far as I understand, we are the world's first in that space. And in order to do that, a few things that lead us there. First is we're focused on mechanized and mineralized highest permanency carbon removal, government-backed, and what that means is we raised a $75 million Series A in the fall. Of that, 25 million is an investment Canadian, so like 57 million in real money. So 25 Canadian million of that is coming from a direct investment from equity from the Quebec government. We're looking to build a completely traceable technology stack. So every molecule of CO2 that is captured from the air through our balance of plant, compression, liquefaction, transportation, and storage will be monitored and measured and API-able. We're looking at doing both air and ocean, starting with air and ocean soon after. And we're looking at multiple technologies simultaneously to reduce the delivery risk. And of course, we are looking to do a pre-permanent sequestration, multiple forms of sequestration, which I'll go to in a moment. As I said, the technology landscape is very fragmented, very nascent right now, and I have only a couple of minutes, so I'm going to go through this really quickly. That's why we're building something called Deep Sky Labs, which is going to be a testing and validation center. Our vision for this is to bring the best technologies from around the world, and I'll skip all of this. The best technologies from around the world to Deep Sky, to Canada, where we will trial them and understand how they operate in the heat of the summer to the cold of the winter. The best of these technologies, we are going to commit to building a commercial facility, which we're calling Deep Sky 1, with the capacity of 250,000 tons per year as our first step towards a gigaton scale capacity in the years to follow. And to back that up and why we think Canada is the best place in the world to do this, one, we have the storage to reverse climate change. Western Canada literally has enough storage capacity to capture and store every single ton that humanity has emitted since the dawn of the Industrial Revolution. And at the same time, we have an incredible amount of renewable energy. The problem is that they're not necessarily co-located next to each other. In Quebec, the reason why we're Quebec based and founded is because of the access to hydro capacity and hydroelectric grid, some of the cheapest electricity in the world. If you want to do direct air capture, you need the interface of two things, storage and renewable energy. And so Canada as a country has that. Now we have to figure out a way to get them co-located. So in total, just to wrap things up here, what makes us different? What do we actually do? The way to think of our business model is just like how we're an oil and gas company in reverse, think of us like an oil and gas company. Large major oil and gas companies don't necessarily build their own technologies. They buy catalysts from BASF. They license technology from Honeywell and UOP. They contract Schlumberger to drill their wells. But what do? They own and operate the facility. They refine the product. They distribute it to the customer. Our product is carbon removal, and we are going to build and own and operate the facilities to deliver on that. And we are partnering with technology developers we will either license or actually purchase the units outright as OEMs to build those projects. Maybe I'll stop there just because I know we have limited time. And happy to answer any questions from the audience offline. Google my name, look us up. We're very easy to find. Thank you so much.
You'll find a lot of publications under that name as well, and a storied history. Phil, thank you very much for joining us today and giving us that showcase. It really actually highlights the fact that for CCUS in particular, compared to a lot of the other tax credits, I think you're going to see a really interesting mix of projects, large companies, small companies that are going to be able to make use of this particular tax credit. So I think it's going to be really interesting to see who ends up being able to leverage this. So thank you very, very much. I want to move over to Alicia, and you should be able to share the screen, or I can as well, whichever you prefer, Alicia.
I will start sharing now. Here we go.
And Alicia joins us from Enbridge, and I'm going to put a little plug in for the Ontario CleanTech Industry Association, which she also sits on the board with me. So over to you, Alicia.
Yeah, thanks, Brian. I'm so excited to join everyone here today and speak a little bit more about CCUS. I've enjoyed the conversation so far, and hope to be able to add a little bit around what Enbridge Gas specific, somewhat to Ontario, but with commentary that could be applied more generally around the ITC and how we're, I guess, moving forward with the assumption that it will proceed so that we can be ready essentially when it does. My role within Enbridge Gas is within our technology development team. So similar to how Phil just described a project developer as opposed to a technology developer, we are kind of in that project developer space. And I specifically do quite a bit of research and better understanding of the different technologies that are out there and existing that can help our customers reduce their emissions or improve energy efficiency overall, with the goal of achieving net zero and going through this energy transition. So kind of a unique group within Enbridge specifically, and an interesting role that combines both the technology as well as interactions with our customers day to day. Enbridge Gas, for those of you who don't know quickly, is the gas utility based in Ontario. We are the largest gas utility in North America by throughput. We serve about 3.9 million customers. And our big focus going forward is this energy transition, and how do we do that? How do we achieve this? And how do we guide customers in ways that they might be able to do this most effectively, efficiently, reliably? All of that is extremely important. One of the other interesting and relevant points on this slide too is as Enbridge Gas, we are Canada's largest integrated underground storage facility. So it's a really interesting fact about our part of Ontario. Down near Sarnia, there's the Dawn storage facility, and you'll see why that's relevant to what we're doing in terms of CCUS within the next couple of slides. So overall, the way that we see CCUS, we speak very broadly with lots of different customers, early stage technology, mid stage technology, various TRLs to better understand where we can pair a customer who has a given net zero need with a technology provider who might be able to help them achieve that. And when that comes to CCUS, it's the full value chain. So we're looking at different carbon capture technologies, use technologies, and storage technologies. And today I wanted to focus specifically on use and storage or sequestration, because I think those are important parts of the ITC, of being eligible for the ITC, right? You can capture the CO2, but if you have nowhere for it to go, then you don't have the ITC, or you certainly can't apply. And in Ontario, that's been a specific hurdle for us, is carbon capture may not have developed kind of as readily because there was nowhere for the CO2 to go. And up until March of last year, you weren't actually allowed to sequester CO2 underground. So we've gotten through that part now, and now it's really, we're into the big work of developing storage and utilization options for that CO2 to go to. So in terms of storage, Enbridge is actually readily working on developing storage in the province. You'll see a map here that shows where some of the geological storage opportunities exist for our province. This is a Ministry of Natural Resources study from 2007. And that was kind of the jumping off point for us to take our knowledge of underground natural gas storage and extend it to underground CO2 storage. So we are in the process of submitting for special project permits to drill test wells in these areas to better understand the commercial viability, the safety, and really how effective storage could possibly be for the province of Ontario. As you can see here, we've got an interesting graphic that shows storage of CO2 is much, 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 much deeper than any well table, water well table, any natural gas storage. 2 heights of the CN Tower, which I don't even really think that I can fully conceive in my brain, but very, very deep underground. And it's to those levels that we're planning on going to better understand what the porosity, permeability, and geological readiness is for CO2 sequestration in our province. Similar, or I guess kind of along the lines of storage, in order for us to be able to send CO2 somewhere, given that storage, as you saw in that last map, is really only in a couple of locations in Ontario, utilization has become a really important way to consider different volumes of CO2, as well as more geographically distribute the permanent removal of CO2. So if, for example, there's CO2 that needs to be collected and then permanently stored at an industrial emitter that's really far away from any location where geology could possibly exist, utilization becomes an extremely important option for an emitter to be able to reduce their emissions and, in addition, qualify for the ITC for a given project. So as mentioned earlier, the only one of the gaps that I see in the ITC is that the only allowable use of CO2 is in concrete. And from the work that I'm doing and actually continuing to work on with a couple different other industry stakeholders is that there are other CO2 options that are permanent removal of CO2, which I think is an important aspect of all of this, but permanent removal of CO2 in other use cases that provide value, have a good life cycle analysis, et cetera. So this is one of the areas that I'm focusing on developing and better understanding how that could be incorporated to give more options to industrial emitters for emissions reduction through carbon capture and use. And I have a picture here of one of Enbridge's kind of flagship projects. Again, and just in the interest of moving things along and getting things going, we have a CleanO2 unit, which many of you may know of as the soap company, installed here at our office in Toronto. It's connected to the flue gas of one of our boilers, combines the CO2 from the boiler with potassium hydroxide to make a potassium carbonate that then goes into making consumer products, notably soap. And the other interesting part of this is the waste heat recovery that also comes along with capturing the heat from the exhaust as well as the heat of the reaction. So this was one way for us to move forward and demonstrate the ability for CO2 to be captured from various flue gas streams, not just kind of your typical absolutely massive oil and gas facility or something like that. It can also be done at different scales and done relatively successfully as well.
Mm-hmm. I did not know that you had one of CleanO2's pilot facilities there. So that is great to see because it's exactly the type of use that we want to open the aperture a little bit more on and see these credits apply to a little bit more readily.
Exactly.
And that's actually, even just a day or so ago, and it's probably a good segue to carbon upcycling. But there was an article in, I believe, the Globe, and Susan Rohack from BDC certainly highlighted the article as well, just talking about the fact that use should be as much, if not more, of a topic than the storage, and we don't see that as much. So, really happy to see that you are highlighting that, and yeah, that's perfect. And that's probably a perfect segue over to
sounds good.
our friends Ryan at Carbon Upcycling. Ryan, over to you.
Perfect. Thank you so much. Yeah, what a segue. I appreciate the being teed up like that. Let me just pull up these slides here. All right. Yeah, so quick introduction from my side. Ryan Borns. I'm with the Carbon Upcycling team. We're a Calgary-based carbon CO2 use company, founded close to 10 years ago. And yeah, we're headquartered in Calgary. We do have some exciting work that we're doing in Ontario, which I'll get into a little bit later on here. All right, so we are, as a CO2 utilization company, we are predominantly focused on decarbonizing the built environment and the materials that go into the environment and into the built environment. Our main partners are in the cement industry. Cement, and I'll get into kind of what is the difference between cement and concrete, because it is an important differentiator here. But cement, along with a couple other industries, they're what we'd call hard to abate. Just the sheer chemistry involved in producing cement requires the release of CO2. So it's a very tricky industry to decarbonize. There's only a few levers that they can ultimately pull on. And that's why we're focused on not only how can we capture the CO2 from these plants, but also how can we help to substitute some of those materials. And I think it's been alluded to kind of the difference between CDR or direct air capture, DAC, the difference between point source capture, which is what we're focused on in these situations, and then the avoidance of CO2 as well. We're more than happy to work with direct air capture CO2, but for the time being, kind of the scale that we're looking at, the integration with these partners, working with these point source CO2 emissions is a great kind of next step for us as a company. And I skipped right past this here, but the difference, just quickly for everyone's context, cement versus concrete. I think of cement like the flour, concrete is more like the cake. So it's the binder that's required to make the product. It's only about 10% of the input into concrete, but it is about 90% of the CO2 emissions. And across Canada, we have about 14 operating cement plants and about 1,000 ready-mix concrete plants. So the rolling trucks that you see that pour concrete, about 1,000 of those supplied by only 14 cement plants. So very centralized in terms of where the CO2 emissions are coming from within that industry. I mentioned that there's only a couple levers they could pull on here. So not only do they need to capture CO2 emissions at their stack, but they also need to look at alternative materials that they might be able to utilize to reduce what they call clinker factor, which is the material, the main material for cement. So looking at how can they find alternative materials that make sense. And kind of a cruel irony of decarbonization from the power sector is that with coal-fired power going away, fly ash is a really good substitute for cement, and that's starting to go away. And as the steel industry starts to switch over to electric arc furnaces, which is a cleaner way of producing steel, well, now they lose a good byproduct from conventional steelmaking and blast furnace slag. So kind of the two best substitutes right now, we're starting to see those shift away. So it is a tricky situation for the building materials industry. And that's where we come in. So we have a system that allows us to utilize CO2 at relatively low purities, not atmospheric, but low from an industrial standpoint, anywhere from 4%, which is what we're doing in Calgary, around 20%, which is what we'd see at a cement plant. And we utilize local low-grade industrial byproducts. So not the conventional fly ash and blast furnace slag that the industry uses today, but ones that are going to be more localized, looking at different types of steel byproducts, those sorts of things. And we combine that in our reactor to just jump ahead here. We combine that in our reactor to produce what is called a CO2 enhanced supplementary cementitious material. And this is a patented process that we've been working on over the last number of years. Something that it really started at basically the size of a cookie jar. And now we're producing, or we have the capacity to produce a few thousand tons per year, and working on projects that will be around 30,000 tons per year. But yeah, the main steps here, mechanical activation of the material itself. So taking that industrial byproduct in the presence of CO2 and activating it in our reactor. Then we have a second stage that's more focused on the carbonation, or you can think of it like rapid mineralization, creating carbonates, which is a permanent bond for that CO2. And then the end step for us is just making sure that the material is provided in such a way that the cement and concrete industry can utilize it. Just as I mentioned previously, we do like to be integrated either at the cement plant or at the source of material, just so it's a little bit more centralized. We can hit larger scales, but the fact that we can have either the source material or offtake of material and the CO2 in one location is a nice integration opportunity for us, and just it's a little bit easier for us as opposed to going downstream to the thousands of ready-mix plants instead. As mentioned, we have scaled up quite significantly in the last number of years. Really around 2018 is when we started to focus on cement and concrete. There's other applications that we've been working on, but once we really identified that this was an opportunity for us, we could create high value, high performing cement substitutes while sequestering CO2. Things really took off with some of our industrial partners. And we are now getting into some of the larger projects that I mentioned previously. One of which is going to be just outside of Toronto, Mississauga, where we're working at one of Canada's, if not Canada's, biggest cement plant, capturing CO2 from their stack, utilizing another low-grade waste that does not have a high-value use case today, and creating something that is a direct one-for-one replacement for cement because of the high reactivity that we've been able to demonstrate there. And in addition to that, just a few other things that we are working on. We have this system is quite flexible in the source of CO2 we can use and the source materials that we can work with. So from that, we've been able to expand our portfolio, our tech portfolio, and identify other opportunities for this rapid mineralization. So it's not just cement and concrete, although that is the focus today. But there's other applications that we can look at as well. And that's something that we're continuing to develop, because we really do think that there's an opportunity to localize these opportunities from a source of CO2 perspective. And if there isn't the geologic storage available that we've seen in the last two presentations, if that isn't available to local CO2 emitters, then we're a nice substitute for that, where we can actually utilize the CO2 for beneficial purposes. And of course, we have some very strong partners that have helped support this. So not only just the cement industry, but also kind of our more conventional financial help as well from our investors over the last number of years. And with that, I think I'm only a couple minutes over, which is pretty good for me. But yeah, thank you very much for the opportunity to talk about what we're doing from a carbon capture and utilization perspective. And we're excited for not only what's going on from a tax credit perspective, but just the what we're seeing from a technical perspective in the industry, and starting to see more and more projects come together. It's fantastic to see.
It really is fantastic to see. Thank you very much, Ryan. And actually, there's a question in the Q&A, and I was going to leave those to mostly the end, but there's actually a nice divide, not on purpose, between project site owners with Deep Sky and Enbridge, and companies that are more technology focused companies partnering with folks. There was a question about basically, how do those partnerships work? Do you need to have permits for working on their sites? ECA, I'm not sure what that one is. You might know, but basically, how are you accessing those sites? And Heather, I might throw the same one to you afterwards, if it's something that you can share. How does that work?
Yeah, it's well, with any new project, there's always those fun kind of hurdles that we get to work with. So there's going to be the conventional ones that we have to deal with from building permit perspective. We are creating a new operating facility on these sites. Luckily, from a brownfield perspective, a lot of the things are already in place, and so it's a matter of just making sure that we're not pushing any sort of facility over their existing limitations. From like a cement industry perspective, kind of the two environmental considerations will be the emissions and what the composition of those emissions are, but also any sort of dust, and I guess also noise as well is always one that we always get to look into. But there's relatively standard off-the-shelf equipment that we get to work with, that we plug into our systems, so that we're meeting all of those industry specs. So there isn't much of a concern from that perspective. And yeah, it's just more a matter of making sure that we're meeting kind of the local regulations and fun stuff like that. But no, I think that the fact that we're working with existing operating sites gives us a good head start on those things, although a lot of those tend to be a little bit slower than we want to anyways. But that's all the fun of developing projects.
Great. No, thank you very much. And it is an interesting differentiation between the first two. Thank you, Ryan. And Heather, I know you were on the road, because not all sites are necessarily great with connectivity. So are you there, Heather?
I am here. Can you hear me? I am actually on the road, so you might get some background from the car, but
no problem.
You can hear me okay?
Can hear you fine, and I'm going to pull up your slides here, and just tell me when to next slide when you want me to. So
perfect.
Sorry, give me 1 second here. You
Sure.
can start.
Yeah, so we're actually on the road back from our pilot site. So we are based in Ottawa, and just coming back from Bath, Ontario. Lovely drive along the lake, but a little bit spotty with the reception. So apologies if I'm going in and out. But yes, I'm Heather Ward. I'm the CEO and co-founder of Hyperion Energy. We are a carbon tech startup based in Ottawa, and we say that we're helping companies clear the air. So the next slide, please.
Okay.
And the last few presentations have been a great queue up for my deck here as well. We are working on carbon recycling. So really the U in the CCUS, utilization. So we turn dirty air into dollars by capturing and converting waste CO2 emissions from hard to abate industries and turn those into some of the world's most widely used mineral commodities. And these commodities go into making various different products, including concrete, which Ryan just talked quite a bit about in terms of the impact, specifically around cement and the emissions 8%, which is four times more than all aviation is what we're getting from the cement industry currently. So next slide.
Next slide.
Perfect. What we have created is the world's first carbon recycling system. So this is a containerized drop-in unit that is capable of removing 98% of CO2 emissions. And we are creating a mineral that has a high market value. So really looking at the economics that have been one of the large barriers to adoption and scale up is the actual cost of the capture, and then of course what you do with that CO2. So instead of burying it in the ground at a cost, we're actually turning it into a very valuable mineral and actually displacing a mine source in traditional supply chains of this material. So next slide.
There you go.
Okay, so how this works, it's a circular carbon solution. And our primary early adopter is the cement and concrete industry, because this works beautifully with them not only having the point source emissions that we want to remove and mitigate from getting into the atmosphere, but also they use this mineral in the making of concrete. So what we do, and we're just actually traveling back from the Lafarge Folsom, Lafarge Canada plant in Ontario, in Bath, where we've got this setup of our containerized unit dropped in here. In the first step, we remove the CO2. We capture that directly from the flue gas using traditional scrubbing methods. So our secret sauce is not the capture. We're using proven technology there. Really, our proprietary process here is the second step that cleans and converts the CO2 gas into a mineral solid. And that is a precipitated calcium carbonate. So we use a reactive mineralization process, essentially speeding up a natural chemical reaction. And we're left with a high value, high purity calcium carbonate, which can be reused on site or shipped to other locations. So for the next slide. Really, we're looking at the high performance minerals PCC, precipitated calcium carbonate, that permanently stores CO2. So we're again driving the circularity by creating a mineral that's used widely by industries, including that primary market of concrete and sustainable building materials. This also displaces the amount of cement that is needed for concrete. It's a strengthener and a binding agent. And again, an additional environmental impact is that they don't have to source this from a mined source, which is quite carbon intensive. So we're replacing that in supply chains. So making a useful high demand material. And just in terms of CCUS in general and the concrete and cement market, that is the fastest growing market demand. It was up 175% in 2023. So really getting around some of those barriers to adoption, and the ICT tax credits will help drive those projects as well. Some of the secondary markets that we have for mineral include sustainable packaging, health pharmaceutical products, toothpaste, many different use cases here. And just next slide, please. I won't spend too much time on this, but essentially 2018 was when we got our start. My co-founder, Jerry Flynn, who is a chemical engineer or CTO and inventor of our patented process, was scouted for the COSIA Carbon X Prize. He is originally from the US and married a Canadian. So we got him up here in Ontario. We built our system prototype for that in 2018, right in our backyard in Ottawa. And next slide. And 2022, right through the thick of the pandemic, we decided to manufacture, scale up our technology. We scaled up by 500%, built our pilot system, again, here in our backyard in Smiths Falls with a local manufacturing site. And we validated and tested that mineral. We had some grant support from the Natural Gas Innovation Fund in Alberta, and Enbridge being one of those partners to create on a pure natural gas stream, show that we could make a very high purity calcium carbonate product that would be to spec of the market we were targeting. And next slide. And in 2023, we had our big milestone of installing our pilot at the Lafarge Canada, Ontario flagship cement plant, where we are capturing CO2 and have a fully operating system at a TRL 7. The plant supplies the connections to the CO2, water, and electricity. And again, the mineral sample validation was key here because we proved the other end of the spectrum that we could make a pure product that would be a very high grade, high price point with sort of a dirty cement flue gas stream that was coming from a cement factory with low concentrations of CO2 and high impurities. And next slide. And then this year, we are into our scale up for our 10x demonstration system, which will be rolled out next year. So refining our offtake and also working on some using waste inputs to keep our footprint down and also just the cost down. So we're part of the new Mission from Mars CDR cohort, and we have some various other partners as well that we've been working with across the country. And next slide. The economics, so really, again, unit economics has been one of the major barriers to CCUS adoption. So for us, for every 1 ton of CO2 that we capture and convert, we get approximately 2 tons of a mineral product, which has an average wholesale of about $500 a ton in terms of the use case in green concrete. And next slide. So what that looks like in terms of our business model, we actually sell the mineral to support the projects. And for every ton of CO2, we're essentially leveraging more than $1,000 a ton of revenue. So every ton of CO2. So in addition to a carbon credit, which we've seen various policy initiatives and different barriers, and certainly having been in Ontario since 2018, experienced that as well. So we wanted to really create a mineral that had a high market driven value. And so being able to get 2 tons of that for every 1 ton of CO2 allows us to leverage more than $1,000 a ton of revenue, giving us a really great profit margin on the cost of capture and utilization. And next slide. And so, all of these technologies are needed. There will not be any silver bullet solutions. So we're really happy to see the convergence and collaboration that happens across the industry. A rising tide lifts all boats. And so it's really great to be part of communities like the Mission from our CDR cohort and see how we sort of compare and contrast against what others are doing. Really what sets us apart is that we are creating a green mineral, a permanent storage of CO2. So as opposed to something that would, like a fuel that would re-emit down the value chain, we do have that permanent storage. We've been able to create plug and play technology, working in collaboration with Lafarge for the past 5 years to really get over some of those barriers to adoption. And I know one of the questions about projects, permitting and that kind of thing, really to adopt the best practices and standards that a company like Lafarge Holcim, the world's largest provider of sustainable building materials, has. And so we really follow along their health and environmental policies. We offer the plug and play technology that essentially can be dropped in on site, which helps us also get around a few of those construction barriers. And then it is removal at the source. In the future, we do hope to potentially work with other forms of removed carbon, whether direct air capture and so on. But right now we're looking at trying to quickly mitigate CO2 from getting into the atmosphere. And then again, the favorable unit economics and the low cost CCUS set us apart as well. And next slide. So we have great community of partners. We were part of Techstars Equinor program in Norway, supported by the National Research Council IRAP program. And we've just raised just under $3 million to date to get us to a TRL 7, which is quite capital efficient, I would say. Some of our notable investors, the Capital Angel Network in Ottawa, and Thistle Capital, which is the family fund of Shopify's founder, Tobe Luque. And again, some of the great accelerators that we work with across Canada. We were supported by CTTCs seed fund, and of course, in the early stages of pre-commercial, pre-revenue, things like grants and of course tax credits are very important to us as we try to commercialize. And next slide. We have been fairly stealth mode to date, but we are going to be putting out some exciting announcements in the next month or so, so stay tuned for those. And next slide. And this is just a summary of our feedstocks, our process, the products, markets, and some of those numbers that we're targeting. So again, using waste inputs, the waste CO2 to create a valuable mineral that has a high market demand and price point to really push forward decarbonization. And I think that's the last slide. Next slide, Brian, I think is going to be my wrap-up slide. Yes, thank you so much. Hopefully that wasn't too loud with the background noise here on the road, but appreciate the opportunity to speak to everybody today. And we're definitely looking forward to the new tax credits as we look to our scale up.
No problem, Heather. That's absolutely perfect. And there is actually one question that might be a good one for you to answer if you're comfortable doing so, which is basically, can you provide an example of a revenue sharing model that you would use with an industrial emitter, i.e. if you're capturing their CO2 using your tech and generating voluntary credits, how do you avoid double counting those reductions, compliance versus voluntary? Is that something you've dealt with, Heather? I suspect it has.
Yes, so essentially we are not reliant on selling our carbon credits in the voluntary market to create revenue. So that is, it's such a small part of our revenue model, where mineral really is what the primary revenue for us is. So we're not necessarily selling the machinery or the systems or even the carbon credits. So that allows us to offer that to our partners as a benefit for them to claim those carbon credits as they see fit. And again, just the move away from having that as our main revenue source allows us to have those revenue sharing or value creation opportunities for our partners. But that is a model that may change in the future, but that's so far kind of what we've looked at is just a purely market-driven commodity revenue source.
Great. Thank you very much, Heather. And with that, I want to say thank you to all of our speakers today. It's been really great having a pantheon of different technologies in the CCUS space. There really is quite a lot of diverse. I mean, we've got soap to concrete. Both are start with the letter C, but I don't know that you can get more diverse to capture geologically. So thank you very much, everybody. I'm sure there will be more questions. We certainly have them around the tax credits. We will certainly be keeping people up to date. Mark your calendars for what looks like June 20th. That will likely be our next webinar in this series, focused on the CleanTech tax credit. So that's your batteries, your panels, your geothermal, and the capital expense of implementing same. So we'll be diving into that and showcasing some of the technologies that could be covered under those tax credits. And hopefully by then, And I know I've been saying this for almost 2 years, but hopefully by then we will actually have legislation and forums to claim these tax credits against. So thank you very much for everybody joining us today. Thank you very much to our showcase companies, to Jeff Keats from EDC and Corey Conroy from EY, and of course Jonathan Garbut from Dominion Tax Law. Everybody have a wonderful day, and we'll speak to you soon. Bye-bye.